Hello. Today we're learning about composition of functions. So the notation f of g of x, which you see here, is used to describe the composition of functions. So that means that you plug in the function g of x into f of x every time you see x. So we're basically plugging in a function into a function instead of a number into a function. Sometimes. Sometimes we still plug in a number into the function. So let's look at example 1. We need to find f of g of x and evaluate when x equals 4 given these two equations. So this means that the g is inside f, so we're taking g of x and plugging it in to f of x. So we get, f of g of x, when we plug it in, we plug in x plus 5 instead of x. So we get x plus 5, and then you square it because of the f of x. Well, then it asks us to evaluate when x equals 4. So we found f of g of x, but now we need to find it when x equals 4. So we take that x equals 4 and plug it in for x. So we get 4 plus 5 squared. Well, 4 plus 5 is 9. So you have 9 squared, and that's 81. And that's your answer. So you can go that way. You can plug in g of x into f of x, or if it says g of f of x, the f of x is inside, which means you're taking your f of x and you're plugging it into the g of x. So we have g of f of x, and instead of x we have an x squared. So we need x squared plus 5. Then it says to evaluate again when x equals 4. So we plug in that 4 right there. So we have 4 squared plus 5. Well, 4 squared is 16 plus 5. And 16 plus 5 is simply 21. Notice that whenever you do g of f of x, even though we're using the same functions and the same number, we don't get the same answer. So you have to be very careful about which one you're plugging in. You're plugging in the inside one into the outer one. Okay, so now that you've seen that, we can use composition of functions. You can use the composition of functions to determine whether or not functions are inverses. Remember when we did inverses, you swap x and y and solve for y. So to check and make sure you did it right, you can plug it in. So if f of g of x equals x when simplified, and g of f of x equals x when simplified, then f of x and g of x are inverses. So it has to work for both ways. Okay, it has to equal the same thing no matter what you put, whether you put g of x into f of x or f of x into g of x. So let's look at what this looks like. Determine whether f of x equals 2x plus 4 and g of x equals x minus 4 over 2 are inverse functions. So we need to have f of g of x. So remember for this one, this means that we plug in g of x into f of x. So we have 2 times our g of x, which is x minus 4 over 2, and then we have plus 4. Well, we need to simplify this as much as we possibly can and get it down to whatever it's going to end up being. Well, we have a 2 over 2, so they cancel. So we get x minus 4 plus 4. Well, negative 4 plus 4 is 0, so these also cancel, and we get x out. Okay, so since they simplified to x, then we're good. Now we have to try the other way though, because we have to make sure it works both for f of g of x and g of f of x. So let's, instead of plugging in that way, we're going to plug the 2x plus 4 into x here. So we're looking for g of f of x, and we get the 2x plus 4 in the top, so 2x plus 4 minus 4 over 2. So instead of x, we put in the 2x plus 4. Well, that means we have 2x plus 4 in the top minus 4 over 2. Well, 4 and negative 4 cancel, so we end up with just 2x over 2, and 2 over 2 cancel, so we get x. Well, this also simplifies to just x. That means that our answer is yes. they are inverses. All right, let's try that one more time. So we need to determine whether f of x equals 2x minus 9 and g of x equals x over 2 plus 9 are inverse functions. So we still need to do both the f of g of x and the g of f of x. So the f of g of x is when you take your g of x and you plug it into f of x. So we're going to plug it in right there. So we end up with 2 times our x, so the g of x. So we have x over 2 plus 9 minus 9. Now we know that if you have two terms inside, then we have to distribute. Okay, so we get 2 times x over 2 plus 2 times 9, which is 18, and then the minus 9. Well, 2 over 2 cancel, so we end up with x, and then 18 minus 9 is 9. So we have x plus 9. There's absolutely nothing we can do to simplify this, which means that this does not equal x. Because one of these doesn't equal x, we can go ahead and stop and say that no, these are not inverses. Because it doesn't equal x. And that's it. That's all we're doing. We're plugging one equation into another. Have a good day.